December the 11th, 2016. This is an illustration of a black hole consuming a star such as our sun. Now, when you're dealing with what we're going to talk about in Cygni 404, the sun that's being consumed is about 50 times larger than our sun. This is also an illustration of that happening and the outthrust of energy in whatever direction it happens to be in at that time. But 404 Cygni lies in the constellation Cygnus at a distance of about 8,000 light years from Earth. It's a binary system comprising of a black hole and a star orbiting one another. 8,000 light years, guys. Remember the video yesterday when the 9.1 struck the planet? That system was 55,000 light years away, not 8. And this type of binary material flows from the star towards the black hole and gathers in a disk where it's heated up, shining brightly at optical, UV, and X-ray wavelengths before spiraling into the black hole. Now, on June 15th last year, the first signs of renewed activity in this system were spotted by NASA's SWIFT satellite, detecting a sudden burst of gamma rays and then triggering observations with its X-ray telescope. Soon after, the Japanese MAXI monitor, the all-sky X-ray image, observed an X-ray flare from the same patch of sky. Now, the entire world turned to this burst last year. As part of the worldwide effort, European Space Agency's Integral Gamma Ray Observatory started monitoring the outbursting black hole on June 17th, 2 days later. The behavior of the source is extraordinary at the moment, with repeated bright flashes of light on timescales shorter than 1 hour, continuous outburst waves of energy, something rarely seen in other black hole systems. In these moments, it became the brightest object in the X-ray sky, up to 50 times brighter than the Crab Nebula, normally one of the brightest sources in the high-energy skies. Since the first outburst detection of June 15th, listen, the system has remained very active, keeping scientists extremely busy. Why is everything focused in that direction? There are only a handful of black hole binary systems from which data have been collected simultaneously at many wavelengths, and the current outburst of V404 Cygni offers the rare chance to gather more observations of this kind. Again, multiple sources, multiple data, different wavelengths, and they're saying it's an extreme object, has woken up again. We're eager to learn more about the engine that powers the outburst we are observing. It's coming out of Switzerland. Now, I want to interject a head note. Van Velsing, part of this study, looked at 5 possible tidal disruption events and saw the light echo and effect in 3 of them. James' group saw it in an additional event called Assassin 14 Li, or Li. Now, the system that we're looking at, Cygni, is 8,000 light years away from our planet. How far can this energy travel? Hubble caught a NGO, and it was also caught with ground-based X-ray imaging, and it showed a tremendous distance of about 86,000 light years as far as how far this energy traveled out, guys. Check this out. It's called the Core of Galaxy NGC 4261. On the right, Hubble images. On the left, in the center is what you're looking at on the right. And that energy is traveling out 86,000 light years in both directions from that explosion. Now let's go back to Cygni. This is a period of about 5 days of images after the explosion in 2015, guys. This is SWIFT satellite. And what you're seeing is up to about 4,000 light years. So it's traveled about 6,000 light years at the outer rings. And the X-rays, as they move from this explosion, and gamma rays are heating up dust particles between there and us. And so as the still images come in, you're seeing it get closer and closer. But again, you're seeing the heating of dust particles. It's amazing. It says the X-rays were centered on V404 Cygni, a binary system containing an erupting black hole. These were imaged by the X-ray telescope aboard NASA's SWIFT satellite from June 30th to July 4th. A narrow gap splits the middle rings. Now, on September 14th, something else happened. And it says that waves of energy traveling for more than 1 billion years gently rattled space-time in the vicinity of Earth. The disturbance produced by a pair of merging black holes was captured by LIGO, or the Laser Interferometer Observatory, in Hanford, Washington, and in Livingston, Louisiana. This event marked the first ever detection of gravitational waves and opens a new scientific window on how the universe works. So we're dealing with different things and different possibilities. We're going to talk about that on the show coming up in a few hours, 6 p.m. Central Time today. I'm going to be a guest with Paul Begley, and so is Mike from around the world. But it says what looks like a shooting target is actually an image of nested rings of X-ray light centered on an erupting black hole. On June 15th, again, NASA's Swift satellite detected the start of this new outburst from 404 Sigma. It says where a black hole and a sun-like star object orbit each other. Since then, the astronomers around the world have been monitoring the ongoing light show. June 30th, team led by Andrew Beardmore at Leicester, UK, imaged the system using X-ray telescopes aboard the Swift, revealing a series of concentric rings extending out about one-third the apparent size of the moon. That's large in the sky, guys, at that distance. Said astronomers say the rings result from the echo of X-ray light. The black holes flare emit X-rays in all directions. Dust layers reflect some of these X-rays back to us, but the light travels a longer distance and reaches us slightly later than the light traveling a more direct path. Are you listening? The time delay creates a light echo forming these rings. Again, they're heating up those dust rings. You're looking at an animation. And in Sigma, the star to the left that's being pulled into this black hole is about 50 times larger than our sun. Again, animation creating this black hole. Now, you'd say, well, when it finally takes that star in, after it distorts it in this egg shape, pulls it all in, what happens to the black hole? It becomes larger and it starts merging with other black holes. There's new evidence of multiple black holes merging very fast. And while black holes are merging, they're pulling in other suns and everything else. But guys, in Los Alamos, the event was caught on their satellite computer. You saw that blue image? And that alerted them. That's ground-based telescope. And this is a simulation of what the events, as they gathered all the information, as it's pulling in the energy from that huge sun, and it's more or less being force-fed by gravity more than it can consume. This energy is converted and blown back out through the galaxy. You see that? And that's what they're picking up. Again, these are the actual Swift images taking up of that explosion. That's amazing, the heated dust rings. So we've got multiple variables. We've got this type of energy that also can produce gravitational waves. Also, do not forget, and you're looking at actual images now from some of the satellites, guys, picking up these binary twins. One is the sun, one is the black hole as they spin. And once the black holes consume the dust particles, suns, planets around them, they start to merge, creating even larger and larger explosions. So what we've seen is with Sigma since 1930, then in the 50s, then in the 90s, and now again 2015, separate explosions, is not from the same sun. I think it's from it consuming multiple objects. But as they merge, the two black holes, it gets really interesting at this point because they start warping time and space. And I think that has a lot to do with the gravitational waves and some of the psychological effects. Mike and I are going to join Paul Begley on Paul's show at paulbegleyprophecy.com. It should be very interesting. We're going to try to narrow this information down, guys. Don't miss it. Heads up. Be safe.